Welcome, guys. So keep solving our physics subject GRE, and be sure to subscribe to my channel. Okay. So the first, we solving number 6 to number 10. Okay. So, forgive me. This part is not the same as this. Okay. So you can read the question by yourself. Basically, there's no friction between wedge and this square, but there's a force between it, and it's stabilized. So basically, we first see the box. We see a box. So box has one force, and two force from here to here. I call it F in the 35 degree. So this mg is 2F times square root of 2. Basically, you take their component, take their vertical component. So this is the first equation. And the second equation is we focus on this mass. Okay, so you have a force here, and the friction called mu n. N is the force which the surface supports this n, and then you also have a mass mg. Okay, so for this need to be stabilized. We need to their vertical component is, and the horizontal component need to be cancelled. So its horizontal component is mu n plus what equals to F. So F can be decomposed into two components. This one and this one. So this is cosine 35. Okay. And this is the horizontal component. So vertical component is n equals to mg plus another F component. Okay, so from these two, hopefully we can solve F into. Hopefully we can solve F because we have mu mg. We plug n into this. Difficult. Okay, so this is what we have. Then all we did is plug this into this. So we times. So we have square root of F equal to mu mg over 1 minus mu. If I times 2 times square root of 2 divided by 2, so 2 times square root of 2 divided by 2F, we have what? We have 2 times square. Basically, we times. Okay, so 2 times square root of 2 mu mg 1 minus mu equals to let me see. So so this one tell us this one, right? So right, this one tell you this one. So we have this one. What I'm doing? Okay, so we have this one, and this tell you that F square root of 2 is mg. So tell me from this and this, I know that if this mg divided by 2, large mg divided by mu mg, you have 1 minus mu. So large m is 2 mu m over 1 minus mu. So the answer is 2 mu n over 1 minus mu. The answer is D. Okay. Okay, so number 7 asks you about you have a stick of large mass m and two small particle, which is small mass m, and there are two lines, basically the two string connecting it, and ask about the normal modes. So basically, you have 3 degrees of freedom, 1, 2, 3. So you have 3 normal modes, 0 and 1, and something he already solved to you, and the rest. Basically, so you see there the system is symmetrical. So if this mass and this mass they move in the mirror motion, so basically if this one move from here to here and then the right one move from here to here, then the system will keep stable because the center of mass does not changes. So must be the third normal mode. So what it means is that the middle large mass m will fixed, and the small m will change. So basically, it's like if we focus on one m, then this is fixed. So basically, this is like a wall. So this is like a simple pendulum. Okay, so you already know that t is equal to 2 pi over L divided by G, and omega just 2 pi over T. So square root of G over L. Answer is A. Okay, so number 8, somebody give you the force and the point and the coordinate, ask you about what's the torque. So torque is basically R cross F. So all you need to do is just use this P cross F, P cross F, P cross F, P cross F, and see which one has negative component at Z. And I think this is the right computation. So let me just do the first one for you. Okay. So the first one is Bj minus Ck cross Ak. So it's J times J cross K is I, right? So the first one is positive x directions. So A is not correct. And you can do case by case. And you can find C should be the correct one. So I think it's direct computation. So I don't want to do, but let me do C for you. So you have. Okay, so this is CK. So IJ is K. You see, so the first one basically is what we need. Okay. So number 9 said there's a coaxial cable. There's I here I from this one this way to this way, and then there's I from the another direction I at the annulus. And ask you about the magnetic field of P. Basically, this is easy question. We just use the Ampere law. So we choose a loop from here to here, and we know that it must be the same by the symmetry. So we have B times 2 pi r equals to mu naught. I enclosed is negative I plus I, so which is 0. So B is 0. Answer is A. Okay, so number 10, you have a conducting plane, so this potential is 0. And then you have a Q to Q. This is half A. This is A. And anyone ask about the force of Q. And anyone took the undergraduate electrodynamics knows about this can be solved by image charge. So we can neglect this one. You can neglect a stupid conducting plane. Oh, and we just okay. So I should replot the graph. Boy, okay, so hopefully, okay, so this is 0 to Q. So you can plot the image charge. Okay, and ask about the force. So this Q have these 3 forces. So negative Q will attract Q, Negative 2 cube will attract cube, and then this one will push this one. So you just sum of all three forces. So the first one is 2q squared divided by a squared. The second one is 2q squared, q squared divided by squared. The third one is 2q squared divided by a plus a for a squared. So you have q squared over a squared 3 plus half. So it's 7 over 2 q squared a squared, and then remember this 4 pi epsilon naught. So the answer is E. Answer is E. Okay, so that's it. I will see you guys in the next channel, next video, and be sure to subscribe to my channel.